Welcome back to another session on DSA. So in the previous sessions we had seen single linked list and I hope you had practiced the programs on single linked list. So when it comes to single linked list, there are certain disadvantages as well. So what are the disadvantages of single linked list is what we are going to see now. So let's assume that I have a single linked list over here. So when it comes to adding an element to a single linked list, there is one disadvantage. And what is the disadvantage if you ask me? It's very simple. Assume that you need to add one element to a single linked list. If you want to add an element to a single linked list, you will be adding at the end of the single linked list. While adding at the end of the single linked list, you would need one reference over here. If you want to get a reference from here, you will definitely have to traverse from starting till the ending, and that's how we have written the program as well. We had introduced a reference called as current, which used to start from the first node and it used to traverse all the way to the last node, and then it used to add the new node. So apart from adding a new node, you are doing a complete traversing of a single linked list. So assume if there are 1000 elements or 2000 elements, in that case the time complexity of this drastically increases. So if you ask me what exactly is the time complexity of adding an element is big O of n. So we have to make sure that we reduce this time complexity and bring it somewhere to big O of 1. And how to do that and all of it we'll be seeing in the upcoming videos. So now, apart from this, there is one more disadvantage. What is the other disadvantage? In case if I have to delete the last element, even in that case, we will have to traverse from starting of the single linked list till the ending of the single linked list. Means I will have to move my reference from the starting of the single linked list till the last second node. So over here also, what exactly is happening is, apart from deleting a node, we are actually traversing the complete single linked list. So this is another disadvantage, and the time complexity of this is also big O of n because it's traversing all the n elements over here. Now apart from this, there is one more disadvantage, and that's one of the major disadvantage. And what exactly, if you ask me, we are capable of traversing from starting of the single linked list till the end of the single linked list, but we are not capable of traversing from the end of the single linked list till the starting of the single linked list. So basically, reverse traversing is not available when it comes to single linked list. Now the question is, how can we overcome all of this disadvantage? So we can overcome all this disadvantage with a new data structure, and that's nothing but doubly linked list. So if you ask me how exactly does a doubly linked list look, this is how a doubly linked list will look. Now if you observe, there are 4 elements over here, but the representation has slightly changed. And what is that has changed if you ask me? It's very simple. I want you to observe a node over here. If I pick any one node over here, usually what used to happen in single linked list is, in every node there used to be 2 parts. One used to be the data and the other used to be the reference to the next node. But you can clearly see over here what exactly is happening is, there are 3 parts over here. One is data and the other 2 are the references. So one reference refers to the next node, whereas the other reference would refer to the previous node. And that's what has exactly happened over here. If you observe over here, this is the first node. It has 2 references. The first reference is not referring to anything. This is the previous one, and this is the next one. So previous is not referring to anything because there is no node before this, but the next one is referring to the next node. Same way, if I take this node, over here I have 2 references. One is the previous. Previous is referring to 15, whereas the next is referring to 10. So you can clearly see the data is only 1, but the references are 2. Now what is the advantage of this if you ask me? Whatever disadvantages we have seen in the single linked list, all those can be overcome. We can overcome those disadvantages with the help of this particular thing. Now how exactly, if you ask me, this will not just have 2 references in a node, it will also have 2 references in the whole of single linked list, whole of doubly linked list. So in case of single linked list, we used to just have something called as head. But in case of doubly linked list, you will have one reference called as head. At the same time, you will have one more reference called as tail, where tail refers to the last node and the head refers to the first node. So in case if we have to add any element, we don't have to traverse from starting till ending. Rather we can, since we already have a reference for the last node, we can directly add an element over here. If we have to delete it, since we already have a reference, we can directly delete it. In case if you have to reverse the or if you have to traverse in the reverse order, since we have something called as previous in every node, we can actually traverse in the reverse order as well. At the same time, we can traverse from starting to ending as well. So this is how we can overcome all of these disadvantages. Now let's write some code and implement all of these things and implement all the methods that we had seen in case of single linked list as well. The code or the logic would slightly change, rest everything would remain the same. Now let's first define the doubly linked list data structure, and moving ahead we'll write many programs over that particular data structure. So first thing is, if a doubly linked list look like this, how exactly should the node be is the question mark. So if I pick any one node from here, so what exactly does this node look like? If you observe, there are three parts in this particular node. Now what are the three parts? One is the major, that's nothing but the data part, and the other two are nothing but referring to the previous node and the next node. So what exactly I have to do is, there are two datas or the two parts which actually refers to different nodes. So there are two datas of node type and one of integer type. So this is how I need to create an object. So if I have to store or create a node like this, an object has to be created, and if I have to create an object, definitely I will have to create a class. So how exactly does a class look like? So class would be very simple. I just have to create a class called as node, and after that I need to first say there is something called as data which is of type integer, and there is something called as previous reference, and there is something called as next reference. Both are of type node. So this is how a node would look like, and if I write a class, this is how it would look like. Now if I create multiple objects of node and if I connect them, that would make a doubly linked list. Now how to actually define a doubly linked list data structure, if you ask me, for this particular thing, definitely I will have to create a class called as doubly linked list. So I will create a class called as doubly linked list. There are two references for this, and two references are nothing but one is head, which points to the first node of the doubly linked list, and one more is nothing but tail, which points to the last node of the doubly linked list. So the class should look like this, where inside there is one head and one tail, which is of type node. So inside this particular class, we need to write the different programs that we would wish to write, like adding an element or traversing a linked list and all of these things. Now let's write the code to actually implement the node and the doubly linked list. So I'd start with creating a node. So how exactly the class should look like? So let me start by creating a node. Before that, let me give some spaces. So I'll put this down completely, and over here I'll start with a class. So I'll say class node. Now inside this node there are three different instance variables. So I'll open and I'll close the brackets. Inside this there are three instance variables. One is data of integer type, so I need to say int data. Next is nothing but the previous node, means in that particular node it should refer to the previous node. So the data type of it is nothing but node itself. So I'll say node previous, PRE. Great. I'll put some next. And there is one more reference that I should have inside this particular node itself, which refers to the next node. So the name of the variable has to be next of type node. So I'll say node next. So this is how I create a class. Now inside this class, I should have one constructor as well, which will actually help me to accept the data and create a node. Now how to have a constructor? Constructor is nothing but same name as class. So I will come to the next line and I will say node. I will open the parenthesis, and within parenthesis it should accept only the data. So what I will do is I will say int data, and inside this particular constructor, what I need to do is, this data whatever I have is nothing but a local variable, and this data is nothing but instance variable. So inside this variable I need to store this data. So how can I do that? I will say data equal to data. Data is equal to data. So this is a wrong way of writing it. This actually is nothing but the local variable, and this is instance variable. So how do I refer instance variable if there is a name collision? All I need to do is I need to refer the instance variable as this dot data. So I'll say this dot data over this dot data. Great. Now after this, these two has to be null. Basically you don't have to write explicitly as null, but just for a better understanding, if anyone sees the code, it's good that they clearly understand this is also null and this is also null. So in the next line what we will do is, we will say this dot previous is equal to null. this dot previous equal to null, and in the next line this dot next equal to null, this dot next is equal to null. Great. So these two lines are optional because by default if I don't assign anything they will store null itself. So this is how a node would look like. Now the only difference that you see over here and see in the single linked list node is just that this particular variable is not available in single linked list, but in this particular doubly linked list this is available. Now what I need to do apart from this is create one more class called as doubly linked list. The same way we had created linked list when it comes to single linked list. So I will create one class, I will give one more line space, and I will create a class. I will say class doubly linked list. Doubly linked list. Great. So inside this class I should have two instance variables. So doubly linked list will always have two things. One is the head and the other one is the tail. But when it came to single linked list, what exactly it had only one head. So it was referring to the first node. But over here I will have head as well as tail, where head refers to the first node and tail refers to the last node. So I will say node type head, and in the next line I will say node type tail. Great. So if I do this much, I have created a doubly linked list. Now if I have to create any methods, for example, if I have to create a method called as add, or if I have to create a method called as remove, all those methods I will be implementing inside the doubly linked list class. So all that we need to do now is just try creating a node and check whether it's working or not working. So what I'd like to do is, I'd like to go to the main method, and inside the main method what I would like to do is, I'll come inside this and I'll say new node. New node. And I need to pass a value to it. I will pass a value 10. Not like this, I will put parenthesis and over there I will pass 10. Great. So I will say control to L, it will give a reference. So I will name it as maybe temp. Great. So I'll come to the next line, and in the next line what I'd like to do is I'd like to print temp.data, temp.previous and temp.next. So I'll say system.out.print. First I'll print temp.data. Temp.data. In the next line I'll just duplicate this line, control alt up arrow, and over here I'll say temp.previous. Temp.previous. I'll duplicate this line and I'll say temp.next. Temp.next. So you can clearly see I have just created a node, I have not yet created any linked list. So in the data part, whatever I have passed has to be available, and in the previous and in the next part, there is no other node or any other node which is connecting with this node. So both of this has to be null. Let's check whether it's actually printing 10, null and null. So if I execute this particular code, if everything is fine, it has to print 10, null, and it's clearly printing. So now we have been successful in creating a node. Now all that we need to do is implement different methods or write program for different methods. So what are the different methods? Maybe we will see how to add an element, we will see how to delete an element, how to traverse the linked list in the forward direction as well as in the reverse direction, and all of these programs is what we are going to write moving ahead. If you have enjoyed this video and would not like to miss any of our videos, hit on the subscribe button and click the bell icon.